Hi, good morning or afternoon, depending on where you're at. Welcome to April's ACPA webinar. Today we're going to be talking about post-installation inspection. And we've got a couple of speakers joining us today. While we give everybody just a few minutes to get logged in, I will take care of just a couple of housekeeping issues. You should see a dashboard for the webinar on your screen. Nobody else can see that. And so that is your dashboard. If you have questions throughout the presentation, feel free to type those in the question pane. You'll see that you can pull that open and send those privately to me. And at the end of the presentation, we'll hopefully have a few minutes and can get much of those answered. Also, PDHs will be available for this webinar. We expect it to be about an hour long, so we'll be able to send out one PDH certificate. If you're sitting with a group of folks that need multiple PDHs, if you will send me an email, my email is kspawn@concretepipe.org. You probably saw that in some of your registration emails, with their name and information they would need on their certificate. Some states require a PE number on there, so if your state does, please include that in your email. If you already registered and you are the person that registered and signed in, I don't need an email. We'll capture that here on the screen. The webinar system captures all of that information. We'll get those sent out to you probably next week sometime. We also record these webinars and we will post this recording on our website as well. So if you have colleagues that missed it or needed to see it and weren't available, feel free to share that with them. So for respect of everyone's time, I will go ahead and turn it over to Doug Holdner. Doug?
Okay, thank you, Kim. So our webinar for February is post-installation inspection, where the rubber meets the road. And I'm one of your presenters today. My name is Doug Holdner. I'm director of the Florida Concrete Pipe Association, which is basically a state chapter of the ACPA. And you're getting 3 presenters for the price of 1 today. I've got with me Angel De Jesus with County Materials, a pipe producer. They're national. They are with me here in Florida too. And then also Sarah Mayton, also with a pipe producer, Rinker Materials. So let's start off with some brief introductions so that you know a little bit about your presenters. I have 23 years of civil engineering experience. Some of that was with consulting firms, and I was with a concrete pipe producer for about 13 years. And for 3 years, I've been the director of the Florida Concrete Pipe Association. While with the pipe producer, I spent about 10 years doing quite a few post-installation pipe inspection assessments and reports. I'm a licensed professional engineer in 2 states, and I'm a Texas Aggie, and I reside in Jupiter, Florida. Angel, tell the audience a little bit about yourself.
Well, hello and welcome to this webinar. I have been in the industry for approximately 41 years, even though Doug claims that I began in 1878, which is not true. I began my experience in the industry of manufacturing pressure pipe. From there, I moved into the design of pressure pipe and installation of pressure pipe, and then migrated into the reinforced concrete pipe industry, where I have remained for the past 20-something years. I'm a licensed engineer in the state of Florida, graduated from Maya West Campus in Puerto Rico, and I presently live in Orlando, Florida.
Thank you, Angel. And Sarah, please tell us a little bit about yourself.
Yes, my name is Sarah Mayton. I am an engineer with Rinker Materials here in the wonderful state of Florida. Prior to working with Rinker, I've been with Rinker for about 3.5 years. Most of my experience was in consulting, doing roadway design, large-scale design-build jobs, site development. My major client was the Florida Department of Transportation. I'm also licensed in Florida. I went to the University of Central Florida, and I live here in Central Florida.
Okay, thank you, Angel and Sarah. So collectively, the 3 of us have quite a bit of experience in pipe inspection assessments, and we'll be sharing with you some of that this afternoon. Now we'd like to have our audience do an introduction of themselves. We have 2 polling questions, and I'll let Kim Spahn handle those.
All right, thanks, Doug, and thanks for the correction on the month. Apparently, I'm way ahead of myself. I got so excited. All right, so on your screen, you will see a polling question. You should be able to click on your answer there on your own screen. So what is your area of practice? We want to know a little bit about who is in our audience today. Are you with a public agency, consulting engineer, contractor or developer, a pipe manufacturer, or an education or university facility? I'll give everybody just a couple minutes to answer that. Okay, we have almost 90% of the folks who have answered this. So let me close that and I'll share it with you, Doug. So 28% said they're from a public agency. Looks like the majority of our folks are consulting engineers, which is great. 3% contractor or developer, 27% pipe manufacturers, so good support there. And 1% from either university or education.
All right, cool. So it's pretty great. That's great to see so many consultants and contractors and public agencies. All right, let's go on to our next polling question, Kim.
All right, the next question, we're going to see a little bit about what type of experience you have within this topic. So again, same thing, you can answer there on your screen. How many pipe inspections or reviews have you performed? First choice is none, 1 to 3, 4 to 12, 13 to 24, or 25 or more. All right, so again, we've had close to 90% answer. I'm going to go ahead and close that one, share the responses. So it looks like we have a good variety, Doug. With 25% said none, 18, 1 to 3, 17%, 4 to 12, another 17, 13 to 24, and another 25% are experts.
Okay, great. So we have a very diverse audience in terms of background and also experience on this. So great, thank you for taking those 2 polling questions. Okay, so now why did I call this Where the Rubber Meets the Road? Well, if you think about a storm drainage project, it's a combination of different aspects. One is the product or the concrete pipe specifications. What I mean by that is that pipe is produced to certain specifications. For instance, it may be specified as a class 3 strength. So that is something that will be vital or important to the project. And then there'll be the design and engineer's specifications aspect of the project. And that could be the minimum or maximum allowable fill depth for the pipe. It could involve the soil types that are specified to be used for the embedment, like A1 or A3, and the compaction limits. And it could be the defined areas of the embedment up to the spring line, or for flexible products to 6 or 12 inches above the top of the pipe. And then the contractor has to execute the installation and follow those specifications and do a proper installation of the storm pipe. And then you have a fourth element, and that's the natural environment. And what I mean by that is you could have natural conditions like high groundwater table above the invert of the pipe. The groundwater could fluctuate seasonally, and you could have tidal influences. In some areas outside of Florida, you could have freeze-thaw conditions. You could have heaving soils. You could have very cold temperatures like you may have right now in February. And those could affect the brittleness or the ductility of the pipe product possibly. And all four of these elements really kind of culminate into that final opportunity to visually inspect the pipe in the post-installation inspection process. And this gives the engineer the opportunity to assess all these factors and how they may be impacting the condition of that pipe before it's put into final service. Our agenda today is going to be what is post-installation inspection, for those of you who may not be familiar, and why it's done. We have some example specifications from agencies around the country. We will talk about the typical inspection and assessment process, and we'll talk about some of the equipment and components of inspection, for example, lasers and measurement systems. And there's assessment criteria and specifications for rendering opinions of the observations. And then we'll conclude with some discussion on benefits and impacts and costs. So, post-installation inspection at its basic level involves running a closed-circuit television camera mounted on a crawler through a storm pipe that has been newly installed. And you can see that here with the camera entering a drainage pipe. Now the cameras come in a range of sizes because pipes come in a range of diameters. You may be inspecting a 12-inch diameter pipe or a 48-inch or maybe even a 60-inch diameter pipe, and it's important that that camera be centered in the pipe, and therefore you have a range of crawler and camera sizes like you see on this image here. Now, some of you may be wondering, why do post-installation inspection? And this is straight out of ASTO, and essentially for a concrete pipe, you want to assess the condition of the pipe and look for any type of structural distresses like cracks or the joint quality, joint alignment, because you want to look for things that may affect the long-term performance of that pipe. And that is a definition or straight out of the ASTO LRFD bridge construction specifications, section 27. Now for flexible pipe like thermoplastics, it's equally, if not more so important. The engineer should be inspecting the shape and any potential deformation of that pipe that could affect its long-term performance. And then there's similar language that's in ASTO LRFD as well, section 30. And there's similar language illustrating the need for post-installation inspection for deflection limits in ASTM D2321. Now, sample specifications. There's quite a few agencies around the country that do require post-installation inspection. This is out of the Kentucky Transportation Cabinet Standard Specifications, Section 700. And what Kentucky requires is that camera video inspection is done on all projects that have more than 250 feet of storm sewer and an ADT of greater than 1,000 vehicles. And I suspect that's quite a few projects would fit that minimum criteria. And what they are doing is inspecting 100% of pipes that are under the road and 50% of pipes that are not. They require that the video inspection contractor be pre-qualified, and then they require deflection testing for flexible pipe up to 48 inches in diameter, and then pipe larger than that, they require some type of physical measurement or a mandrel to inspect for deformation. The Federal Aviation Administration, through AC 150, also requires post-installation inspection, and they stipulate no sooner than 30 days after the final backfill, and they also want the system to be cleaned and flushed, and this is very similar to what you would find in the ASTO specifications as well. And then, of course, that you want suitable lighting so that you have a clear, visible image of the pipe, and like I mentioned earlier, the camera should be centered in the pipe. And our home base of Florida has required post-installation inspections since 2006, and their spec requires that pipe that's 48 inches or less in diameter be video inspected, and they want obviously a video recording and also a report of observations in the pipe, such as cracks and joint gap measurements, tears and things like that. And for flexible pipes, they have the additional requirement of a pipe ovality report. And I'm going to turn it over to my colleague Sarah and ask Sarah to describe the typical inspection process for a concrete pipe from the time a CCTV camera is deployed in the pipe all the way through when you've been given a video and report to assess.
Sure. Doug mentioned AASHTO LRFD Section 27 for concrete pipe. It outlines some of the criteria. We're going to talk about another section in ASTM 1840 that outlines criteria, but those photographs kind of show the equipment getting into a structure via manhole. So basic process, we typically will see the inspection done after it's been backfilled. The pipe is dewatered, which is very critical here in the South. Make sure it's clean, and that's important because we want to be able to see what's going on in the wall of the pipe. If it's dirty, it's more difficult. For the CCTV, they're going to look at any imperfections that the videographer notices. So there is a little bit of judgment there. The report's only going to show what the videographer looks at. So that is important that you have someone who is experienced and certified, maybe NASCO certification. They're going to look at all the joints, take measurements, and we recommend if they see a joint that is out of tolerance to provide more than one measurement, a minimum of 3, so that evaluation can be made if that joint is actually out of tolerance or if it's just a little askew at certain areas. Typically, you're going to see the report given to you in a DVD or possibly Dropbox or some sort of online cloud format. You can see this picture. This is actually a short stack of DVDs. I've had quite a tall stack of DVDs for a large job, so it can be a little long in the tooth to go through things, but you can see that this particular report shows 2 cracks at different locations, and normally we just go through the report in areas that they call out deficiencies. We're not going to look at every foot of pipe. It's just not feasible. So if the videographer doesn't capture it, it might not be something that's looked at by a specialty engineer. So here's a video of an example what you might see, and Doug's going to bring this up, and I'll kind of give us 1 second. All right, we're back. So here you can see the barrel of the pipe. The camera is panning around inside to give us an idea of what's going on. You can see a little bit of dampness, but that might just be at the bottom of the pipe. A little disoriented. There you go. Yep, so that's just at the bottom of the pipe. Looks nice and clean, no water, standing water, and that's per specification. We're going to go up and pan the joint and take measurements after we pan the entire joint. Yeah, that video doesn't show the entire joint, but it would go all the way around 360 degrees. Make sure, take a look at it first, and then provide measurements as required for whatever size pipe that is and your municipality. So continuing, once the report is done and the videographer has submitted that to the subcontractor or the prime, depending upon the job, if there are areas that need evaluation, that will be sent to a specialty engineer. A specialty engineer typically is someone that is employed by the manufacturer of that particular pipe. And that's important because that person needs to have experience in the structural capabilities and the design of the pipe so they can make an accurate evaluation of cracks, of infiltrations, joint separations, if that's been occurring, and provide that evaluation. And during the report, there will be an area where repairs could be recommended depending on what municipality and what's required. And then the contractor, once repairs have been made, will need to re-inspect to make sure that those repairs were adequate. So here you can see Doug's provided an example of the sign and sealing of that specialty engineering document. And depending on what the job is, there's going to be some language in there because typically we're only going off of the video inspection and reports. We haven't visually been on the site, so there may be things that we are not seeing there. So it's important to have that correct language within the report.
All right, thank you very much for that, Sarah. All right, this takes us to our third polling question. Kim?
All right, thanks, Sarah and Doug. Our next question, if you joined us a little bit late, we launched these and you can answer them right on your screen. Would you be able to assess the following crack patterns? Circumferential, longitudinal, hinged, shear crack, broken bell, or an impact crack? Are you comfortable in those assessments? Okay, we have about 80% that responded to this one. I'll close that and share it with you. So it looks like 50% or so said yes, and about another 50% said no, or I'm not sure. So pretty split crowd on that. Turn that back over to you.
All right. Okay, good. Thank you for that. We're going to mention a specification later in this presentation that will help you assess and observing those types of crack patterns. Okay, so beyond the CCTV aspect of the inspection, there is a more advanced stage of the inspection that many agencies require, and that's the measurement aspect. And the measurements are done to measure either observations like cracks and joint gaps, or take measurements of the pipe shape or ovality. And this is done through two separate types of equipment. One is a micrometer and laser calibration system, and this is used for measuring cracks and joint gaps in either rigid pipe or flexible pipe. It employs the use of some fixed lasers on the camera head that are a fixed distance apart, and the operator uses them to essentially calibrate an on-screen micrometer, and they're really just benchmarking or scaling the observations of the joint gap or the crack width with respect to those calibrated laser diodes. And I'm going to show an example of that in a moment. The other type of laser equipment that is sometimes employed is the laser profiler. Now, this is a different type of laser system. This is a laser that is reflected off the pipe internal circumference. So it's a 360-degree laser image. That reflection of the laser off the pipe wall is measured using some software, and it gives a measurement of the percentage of diameter that pipe might be deflected or deformed. So in the case of a micrometer and laser diode setup, if you have the situation where there's a joint gap, and in this particular one, the contractor has measured a gap of about 0.9 or roughly under an inch, And they did that using a micrometer that was calibrated with 2 parallel laser diodes like you see here. So these diodes are mounted on the camera face, and they are pointed 90 degrees at that joint gap. And I'll show you what that looks like here. You could see the image of this is a concrete pipe wall, and you see 2 laser dots right there. Those are those fixed laser diodes on the camera head. And then the black dashed lines are the micrometers that are superimposed on that camera image. And they run through the little laser diode. That's the calibration process. And then that camera operator maneuvers those micrometers to the edges of the joint or to the edges of the crack in order to do that scaling measurement. There's other types of systems. They're the same premise. They may have kind of a crosshair pattern to them. But the important thing that I want you to take away from this is that it's critical for the measurement accuracy that the calibration step be done each time the camera is moved, panned, tilted, zoomed, etc. It must be done for each time. And it also must be 90 degrees perpendicular to the object being measured, or it will greatly impact the accuracy of the measurement. So I'm going to show you a video of a joint gap measurement so that you can get an idea of this in action. Okay, so you have a camera, you come up to a joint and he's panning and tilting at the joint, and they're going to use the dashed black lines to measure that joint gap. But first they have to calibrate them, so they're positioning those lines through those laser diodes. They're calibrating, the diodes are 1.772 inches apart. Now the micrometer's calibrated. They can maneuver the black lines to each side of the gap, and they record an estimated measurement of about 0.35 inch. So that's the calibration process and the micrometer measurement process. Now, the other type of laser equipment is the laser profiler. And this is a profiler that you see here on the screen. And this is for measuring deformation. And so, best to show another video so that you can just see how these things are used. That's the wrong one. Hang on. Got ahead of myself. Okay, so the CCTV part of the inspection's been done. The contractor now connects the laser profiler to the camera and is going to pull that through the pipe. And the software is evaluating this reflected laser profiler image off the interior surface of the pipe. Now, you're probably thinking there's not much happening to the shape of the profiler in this case, and you're right. That's because this is being done on a concrete pipe. Concrete pipe being rigid, there's really no reason to do a laser profiler inspection on a concrete pipe. So they're generally used for flexible pipe like metal, HDPE, polypropylene. And so this is an image of a laser profiler in a flexible pipe. You could see the red laser reflection showing some severe deformation in that pipe, and the green image would be if the pipe were truly round. Now, we often get two basic questions about laser profiling. One is, well, why laser profile in the first place? Why not just look at the pipe or lamp the pipe? And the reason for laser profiling is that it's virtually impossible to detect actual deformation until you exceed 10%, which is much higher than what your typical acceptable limit would be. So that's the answer to question number one as to why laser profile. The other question we're often asked is why limit it to 5% or less than 5%? And the reason for limiting deflection to less than 5% is that you're really limiting the strain in that pipe wall. If the deformation exceeds those limits, then you could have a case where you've exceeded the design strain limit of the pipe, therefore impacting its long-term service life. And you could find further explanation of that in the ASTO LRFD bridge construction specifications if you so choose to look that up. Okay, so my other colleague, Anhil, why don't you walk us through some of the typical issues that may be observed in a post-installation inspection report?
Definitely, it will be my pleasure to do. Typically, when we review a pipeline video inspection, the surface area of the pipe, in the surface area of the pipe, we normally only observe probably less than 2% of that surface area having any degree of observations that may need to be evaluated. When we are performing these reviews, we have to be concerned with the fact that if the TV inspection was performed in accordance to the specifications, particularly the speed of travel of the camera inside the pipe, and if the operator is stopping at each joint and fully panning at 360 degrees the circumference of every joint. That's important because we like to observe the condition of the joints in full. Typically, that's the critical area of any pipeline system, regardless of its application. When it comes to cracks, we are looking for patterns. They can be either circumferential, longitudinal, damage or structural distress on the wall of the pipe, the width and length of those cracks in accordance to the recognized specifications, either by ASTO, ASTM, or local DOT specs. And it is very useful to be acquainted with ASTM C1840 in order to understand the remediation that may be required for each one of those observations. When it comes to joint gaps, some agencies have maximum joint gap criteria, which are, for the most part, in my experience, very useful. But you also will like to consider the allowable additional extensibility that the supplier or manufacturer joint design may provide, since obviously we don't want to be mitigating joints that may not need to be remediated. Joint observations allowance varies by local codes. Some owners require seal-tight joints, soil-tight joints, leak-resistant, and watertight being the most stringent. Pipe wall conditions includes moisture permeating through the wall, and again, ASTM C1840 is very useful in remediating those. I think we are about to show you a video of a longitudinal crack on a pipe. And here we go. You can see the camera that is mounted on those wheels traveling through the pipe and looking at perpendicularly to the location of this crack observation. At this point, there has not been any measurement taken. I believe that we can probably at some point observe the dials of this micrometer equipment on the surface of the pipe. Okay, so here we go with another video that we have on pipe permeability. Notice the stains on this particular pipe. This is a very controversial subject in many occasions because the typical perception will be that there may be some corrosion taking place on the wall of this particular pipe. We show you this video because it happens that this is actually a PVC plastic pipe that doesn't have any steel reinforcement. We have come to know over time, through our experience dealing with these pipeline reviews, that this staining is typically being contributed by the iron content of the groundwater in the location where the pipe was installed.
Great, thank you. Okay, Kim, that takes us to polling question number 4.
Okay, great. Thanks, Angel. Doug? Again, an answer right here on your screen. What resources are you familiar with when making acceptance or repair decisions about your pipe conditions, such as cracks? Either personal or professional discretion. If you've used C1840, you can also, just so you know, select more than one on this question. ASTO construction specs, state or local specs, other or none of these. Folks are still voting, so I'll leave it open just another minute. Okay, and our results are about half of them use professional discretion. We have about a third using C1840, another third using the ASTO construction specs. 70% uses state and local specs, and then 16 other or none of these.
Okay, great. Well, really, all of those come into play. So we're going to talk a little bit about ASTM C1840. So Sarah, Angel mentioned ASTM C1840. Please explain to our audience what C1840 is and why it's important to have in the contract documents.
Sure. Doug mentioned earlier in reference to, to talk about state of Florida initiated video inspection all the way back in 2006. But there wasn't really a complementary document as to what we were going to be seeing when we started looking inside the barrel of a pipe. So in May of 2017, ASTM 1840 was developed by industry, and so industry professionals peer-reviewed this standard, and it really created a document to rely on as to what to expect when doing video inspections and what should be acceptable and what should not be acceptable. This is only for concrete pipe. It reviews crack patterns, size, width, length of pipe, of cracks, where the cracks were occurring, wall conditions as far as water passing through the pipe wall, joint separation, different types of anomalies with the joint based on criteria, as Angel mentioned, if they're water, soil type, leak resistant, of such, and also including environmental factors such as soil conditions, corrosive properties, resistivity, sulfates. So there's some of items in there that can or might not affect concrete pipe. So you can see on this graphic, this is within the specification. It includes in section 7 what the inspection report should require. It also includes how the videographer should be taping the pipe itself, because you don't want it to be too fast, too slow, measurable, how the camera can measure certain cracks. That criteria is important. It gives an evaluation for cracks, which is really important because it is using the design of pipe itself to create the allowable crack criteria. You can see in this photograph, shows an example of a circumferential crack, multiple cracks, and then it's showing that crack patterns using the face of a clock. And that's very important because depending upon where the cracks are located, it's easy to figure out what happened to that pipe and if that particular crack is acceptable based on either it had a point load, and you're seeing that loading on top or bottom, 12 or 6 position, cracking in the 9 and 3 position based on levels of correct compaction and whether those cracks are significant, if they've passed through the pipe wall, if they haven't. So that's very important because it's not just using anecdotal evidence, it's going back to the design of the pipe. Here we see level 1 and level 2 infiltration, and this is really important, especially in areas where you have water passing through the pipe wall based on the type of environment that pipe is in. A lot of times we'll get a videography report, and you can even see on this image in the upper left, it says infill weeper. You get reports that say weeper, stain, dripper, gusher, and those terms really don't have any definition. One person could say stain and then another person say weeper for the same instance. So it's categorizing the amount of flow that's coming through the pipe wall through level 1, 2, or 3 infiltration. And I like to compare that to when we do roadway stationing. And if I say there's a vertical object at 25 plus 00, 50 foot left, people know where that's at, whether you're in the office or you're in the field. So it's a similar nomenclature for all people who are reviewing pipe. So this is very important for that common terminology. And you can see here we reference back to the advisory circular that the FAA provided at the end of December of 2018, which now requires ASTM C1840 to be the standard to which concrete pipe is inspected, which is really helpful. And a huge agency like FAA using this is positive for the industry to know that other agencies can rely on this to be an accurate and trusted criteria specification.
Great, thank you, Sarah. Anhil, okay, why don't you share for those members in our audience that may be considering or in the early stages of a post-installation inspection requirement, talk a little bit about the benefits and impacts that you've seen it have on the industry overall.
Sure. Well, that's the way we used to do it in the old days. We don't do that anymore thanks to CCTV inspections. Final inspections of pipelines bring a consistent, competitive approach to final product inspection and acceptance. It helps all the stakeholders involved in the construction and final acceptance of that pipeline. Obviously, the whole intent is to guarantee and safeguard the longevity of the performance of those pipes. It helps preserve the quality standards expected by the owner, regardless if it's a DOT or a homeowners association or a local government. It plays very favorably in preserving those standards and those expectations of the pipelines.
All right, good. Thank you, Anhil. Okay, Kim, this takes us to our final polling question.
All right. Would you like to be contacted by the ACPA to discuss adding or improving post-installation inspection specifications? Okay, so it looks like, Doug, we have about half that said no and about just under half that said yes or maybe. Just so you guys are aware, if you did say yes or maybe, we'll capture that in the webinar and we'll have somebody locally reach out to you. So appreciate that.
All right, great. Thank you for participating in the polling questions. Okay, well, this is taking us to the wrap-up stage, and I want to share just some final thoughts on post-installation inspection. One is, I imagine some of you in the audience are curious about how much it might cost, and whether or not you have limited experience with this or just want to know what it costs compared to your market. Now, these are some pricing from recent pricing from Florida. Keep in mind that Florida is a very mature market. And there's probably, it wouldn't surprise me if there's close to 24 contractors doing this type of work. Plus, a lot of the underground utility contractors do their own inspections. So it's a fairly competitive market space. But the CCTV itself has a price per linear foot. There's typically an additional cost for the need to do laser profiling on flexible systems. There's some modest cost to putting together the report and compiling the videos. And depending on how much debris is in the line and there needs to be desilting, you have expenses there and for dewatering. Now, I've heard reports from other areas of the country that are more expensive, and that doesn't surprise me. Like I said, Florida is a mature market, but I've seen pricing from Midwestern states that range from $1.75 to $4.75 for 15s and 18s, and anywhere from $2.25 to $11 a foot for 30-inch and 36-inch, and $4 and on up for 48. So just to give you some sense of the price of doing this. Some may be wondering what's going on in my area or what's going on around the country. This map illustrates what's going on in terms of the states that are yellow provide at least a basic level of inspection through CCTV, and the states that are shaded with the hatch markings are basic plus some maybe more advanced measurements like using the micrometer and the laser profiling. So you kind of have a range of at least doing the visual observations, and then some of the states are requiring actual measurements. And then the states that aren't shaded, these are states that either we just weren't able to confirm their specification requirements, or perhaps they're just not requiring it at this time. I'll leave that up for a moment so that you can kind of let that sink in.
Hey, Doug, while
Now,
you,
yeah.
I was going to mention
ahead,
while
Jim.
you had that map up and everybody was thinking about it, that we did have a question on that. Someone was noting that the Midwest, they don't see a lot of states in the Midwest allowing laser deflection on flexible pipe. He said, this is unfortunate, as in larger diameter pipes, mandrels can't always access the pipe. Do you have any suggestions on getting our state to allow this? I thought that was a good question for this slide.
Well, so there's states that are interested in getting deflection testing. They currently don't have it now. It might be a time to first step reach out to ACPA through Kim or through the website. You can find an ACPA engineer for your area, and that might be a first step. And just having a conversation to learn a little bit more about possibly developing that requirement in those states.
Yeah, great, thanks, Doug. I just wanted to add that one while you had it up waiting for folks.
I mentioned several specifications during the presentation. For those of you, maybe those Midwestern states that are interested in implementing a specification like this, you can refer to these. The Florida Department of Transportation standard specifications and the Kentucky Transportation Cabinet, those specs are listed here, and that FAA spec is in the Advisory Circular 150. Acceptance criteria that we discussed, that was the ASTM C1840. You can go to astm.org if you wish to purchase and download that. The AASHTO LRFD bridge construction specifications were recently amended in 2019 for Section 27. There's also Section 30 for thermoplastic. And then the American Concrete Pipe Association has some inspection resources on its website that you could refer to as well. And throughout my career doing this, I often spoke with the equipment suppliers and the inspection contractors, and I found that some were quite knowledgeable and trained, and I found that others were not. But I also found that to just be very valuable to learning about the capabilities of the equipment and the operator, and keeping that in mind when I was being provided with data and reports from which to render an opinion. So I would encourage you, if you're so inclined, to try and learn as much as you can from those resources as well. So Kim, I think we have a few minutes left. If we have some questions we can field from the audience.
Yeah, we do have some good ones. So first question is, do you see an issue with laying straight concrete pipe on a radius, joint issues in particular?
Could you repeat that?
Yeah, they're asking about laying concrete pipe on a radius, and I could field this one if you'd like. ACPA does have a design data if you want to go on our website. I can't remember what the number is, but if you look for design data, we have a whole stack of different design tools, and radius pipe is one of those, and it will tell you how you can design that opening of that joint and how much open you can have that joint to curve a pipe around a corner. The other thing you can do is work with your manufacturer, and they can actually design their joints so that you can lay them on a radius. So certainly work.
Yeah, that's what I was going to say, Kim, is, just depending on what the project is, we do a lot of radius design for a municipality or a specific consultant. So it's all just based on the joint tolerances, the size of pipe, and the type of joint that is being laid. Good question.
Okay, another good question. How does the cost of laser profiling compare with mandrelling, assuming a 1,000-foot line with 3 areas of accessible, flexible pipe deflection? It's very specific. I know you showed cost of laser profiling. I'm not sure if you showed mandrel.
Well, I didn't put it up here actually. The cost of mandrelling is that from what I've seen, well, one, it's not often done in this market in Florida, because we have such a mature laser profiling market. From what I recall, the cost of mandrelling is similar to the laser profiling. However, the difference is that with the laser profiling, you get a complete image or report for that pipe run. The mandrel essentially gets stuck, and you have deformation at that point. So, I mean, it has its advantages, but the profiling is different in the sense that it gives you the profile for 100% of that run. So, from what I've seen, the prices are similar, but whomever asks that, you may want to reach out to the contractors in your area that provide those services and get that information direct from them. Now, there was another aspect of that question. I don't know if I fully understood or answered.
I think they were just trying to give you a length of the line and different areas of deflection, which is kind of what you addressed, that if it gets stuck in one area, you're not going to know what's going on with the rest of the area. The other thing I would say is there are a lot of areas that start with mandrel testing, which I think is great. You're still getting that deflection testing. Just one caution is that you should also require truing rings so that the contractor is ensured to be using the right size mandrel for the diameter of pipe they're using. So as Doug mentioned, with laser profiling, you get a bigger picture and a more accurate picture of what's going on. Another great question, how would you equate the level 1, 2, and 3 infiltration rates to the weeper, dripper, runner, gusher levels of infiltration?
That's a great question. Typically, level 1 we equate to a stain, so the interior of the wall is just wet, no dripping occurring. A level 2 would be what we consider a small, slow drip, so a dripper or a weeper. And then a level 3 would be a gusher, in my opinion, where you're just having a constant stream under pressure of water coming through the pipe wall or the joint, depending upon what the issue is.
Yeah, great question. Another
good question
we had.
Good question. Sorry, go ahead, Kim.
Oh, did you have something, Dad?
I was going to say that it is a good question and a good answer, and those are explained in ASTM C1840 too. So you can get that. Sarah's definitions are very much almost verbatim, with the ASTM C1840 standard.
Another good question related to C1840 is how does that standard compare to the NASCO standard?
Well, regarding the NASCO standard, I'm assuming that might be the PACP, or the Pipeline Assessment Certification Program. And having gone through that, I'm trying to recall all the details on that, but in my opinion, the ASTM C1840 standard is more thorough in terms of assessing a newly installed concrete pipe, and much more thoroughly defines the cracking patterns, addresses the moisture and conditions of the pipe wall. So I would say it's more thorough. PACP being a good program, but the ASTM C1840 provides a more complete element to providing an engineered approach to assessing the storm pipe.
Okay, great. We still have a few more questions here. Let's see if we can get a couple more in. How often is post-installation inspection required?
So how often is post-installation inspection required? Well, I can answer for Florida, and you can maybe draw your own inferences from the map that we showed a few moments ago. For Florida, it's 100% of the time on FDOT projects. There might be a few extreme circumstances on a very short driveway run or something, but it's, for all practical purposes, 100% of the time. Now, for all the 67 counties and municipalities and even private projects within Florida, it is maybe not 100%, but it is a tremendous percentage of those projects as well. So most agencies have followed suit with doing the CCTV and the laser profiles inspections, even on private residential subdivision work. So that's Florida's perspective.
Yeah, and I would say, Doug, it varies by states. a lot of them, many of them do 100% for new installation. Some of them will specify a particular percentage that's done. And then if there's issues found, then they require that 100%. They also have some specifications will require it. I think Doug pointed out one of the specifications talking about no sooner than 30 days after final backfill. That's pretty typical that we see across the nation. Some states even will say, and then again, before they release the bond for that agency to take that pipeline over. So they will ensure that the pipeline is performing per their standards before they take ownership of it, which is a great way to do it. Okay, as we hit 12 o'clock, there are some other questions that we'll be happy to stay on and continue answering. But to wrap up this webinar for anyone that does need to go, I just wanted to reiterate that yes, there will be PDHs available for this session. So we will send those out probably next week. If you registered and are logged in, we have your information. If you are sitting with a group of folks that need their certificates, please let me know. Just send me an email and we can get those out to you. And also there was another question. Oh, there was a great question about, can you discuss repair methods? I think that's beyond the scope of this webinar. However, I love the idea. And we have, as Doug is showing, our April session already set up, and we do these every other month. So I will schedule a repair discussion for June. So we can talk more thoroughly about repair methods and how things are done in pipelines. So as Doug's showing here, April 23rd, always noon Central on a Thursday, we're going to talk about pipe flotation design for all pipe types, and that will be put on by Jennifer Schaff and Josh Beakley. And again, this webinar has been recorded, so again, next week we'll probably get that posted to our website along with a PDF of this presentation for anybody that wants to share it. We would love to have you share it. That concludes the official part of the webinar. Doug and Angel and Sarah, if you guys have a few extra minutes, we can keep running through these questions and make sure we've answered everybody's questions as they
Sure.
That's fine.
move throughout
We
the day.
can, and for those who have to leave, I wanted to say on behalf of the three of us, thank you very much for your time today. We hope that you enjoyed it, and for those of you that are staying on, look forward to hearing your questions.
All right, let's see. Is there any sort of audit in place for CCTV contractor review quality? I know many engineers just look at the reports and the quality seems to vary.
Okay, so any type of audit. Let's try to answer this question. I guess it sounds like what they're asking about is the level of quality of the video itself. And there are some criteria depending on whose specification that you're using that maybe specifies a minimum video resolution. It may specify a rate of speed, of operating the camera crawler through the pipe, and one that's commonly cited is 30 feet per minute. If you're too fast, then you run the risk of blowing by something and not seeing it.
And having the specialty engineer reject the inspection.
That's right. I think the three of us have been in situations where we felt like either the video lighting or resolution maybe wasn't up to the sufficient standard to make a good observation.
Right, and other things we see is, and maybe to the question's point, is not picking up things that they should be, just going through and maybe just getting joints, or we see something and they barely pan to it. There are videographers that will look at a crack or a joint and might not even record the width. So it's really difficult to make an assessment. I have not come across a particular audit, only kind of anecdotally speaking with people on what videographers we feel do an adequate job, because there was a time, still is, where some videographers are also the companies that are performing the repairs, so they may be a little more heavy-handed on some of these reports. So unfortunately, at this time, I have not seen that come across where I've been practicing.
Okay, another question is, does the camera have to start at the downstream and move upstream, or does it matter?
Doesn't matter.
And no, I wouldn't think that it matters. No, it shouldn't matter at all.
It doesn't matter.
Okay, great question. Is there any, oh, that's a Michigan question. They were noting on our map that we didn't have the Upper Peninsula shaded.
Oh.
That's probably just a mistake on our fault, on our parts.
Thank you for pointing that out. We'll get that amended.
Another, yes, we'll have to update that. Another question is there a recommended certificate for a state DOT inspector to have for mandrel or laser profiling of flexible pipe?
A certificate for, could you repeat that?
Is there a certificate for the DOT who's evaluating laser profiling or mandreling? Not that I'm aware of.
Well, the only
other than
certificate, well, I'm looking at this from a different perspective, not the certificate for the person, but the certificate for the pipe. Requirement that I have seen is that the contractor must provide the certified mean diameter of the pipe. So, and from that sense, that would be a certificate, because they need to know that that pipe can be manufactured within a minimum or a maximum. And so they want some type of certification of what that diameter is, from which to be the reference point for those deformation measurements. I'm not sure if that's the certificate that this questioner was referring to, but beyond that, I'm not familiar with, I've not seen any certificates for the person, him or herself, right?
Other than the engineer of record closing of the job.
Certificate of completion,
yeah,
certifying that it was done and that they've reviewed it.
No, that's a good point, because typically
We're talking
what you
about
will have.
The inspector certification.
You know, I've not seen that mandated. You know, it's obviously a good idea to have, an education about, or some types of certifications. The PACP program maybe being one, but I haven't seen that mandated.
Okay, another good question, is there a minimum and maximum diameter that the pipe can be inspected or analyzed?
Well, I think this technology evolved from the sanitary market, and I'm sure they were looking at 4-inch and 6-inch and maybe even smaller. Typically, the storm market is no smaller than 12 inches, maybe even no smaller than 15. Certainly that is possible. We know these can be used in elliptical and arch pipes, and I would not think that there's an upper limit. The important thing would be that you have a camera that's properly sized. If you're running one through a 72-inch pipe, you need a camera that is centered at 36 inches in the center of the pipe, rather than using a camera that's made to crawl through a 12-inch pipe.
Yeah, that's a great point, Doug. Okay, a couple other questions that have come in is pipe replacement typical? Let me reread this. Is pipe replacement a typical mitigation, or are there good on-site repair techniques? And I think that maybe goes back to the same question we had before, that we'll try and get to that in another webinar, is repair methods that are acceptable for particular criteria. You guys have anything else to add on that?
Yeah, I can answer that. Typically, removal of pipe is the worst situation possible. Most issues with the cracks that we've seen can be easily mitigated, and most don't require repair, especially if they're less than 0.05 inches in width. So removal would be a severe separation, severe spalling, things that the structural integrity has been compromised. That's what we're really looking at. Is the pipe still going to provide that surface life, or is the issue that we're seeing within the barrel causing the pipe to no longer be structurally fit for its application?
Great, thanks, Sarah. Another one is, what is the average length that a CCTV camera can travel per segment?
However long the cord is.
Yeah, I've seen broken into around 400 to 500 feet,
Yeah.
but I'm not sure if that was because of the length of the camera or something else. But that I haven't heard a limit.
Yeah, they're connected via a cable, so they're not like a remote control car, so they will be tethered. And most pipe runs are under 500 feet.
Yeah.
Most probably even 300 or less.
300,
So,
depending on the size of the pipe. Yeah.
yeah.
18 to 24 inches. So I would say typically the tether is not going to be longer than the allowable length of the pipe based on minimum flow velocities. So I would say no.
Okay, another great question is there a recommended typical periodic maintenance inspection schedule for pipe?
Oh, good question.
It is a good question. There probably ought to be, right? Where we see the inspections done, where we deal with it is on new installations. So while the contractor is still mobilized, what's the reality of maintenance when?
I think it depends on the size of the municipality. I can only speak for Florida. I know that there are large counties that do maintenance based on hurricane season, which might not apply to many people on this webinar, but that is definitely something, as Doug mentioned, that would be outside the scope of the contract documents. That would be more in municipal code when the city or county or DOT is able to do inspection. So that's something that is not part of what we typically deal with.
Yeah, and I think, FHWA required all states to come up with an asset management plan, I think in the past year or two. Now, that did not require them to address underground infrastructure. However, that's a place we are seeing where some are starting in the asset management realm. They're starting to go look at their pipelines and determine what condition they're in. Now, is that a regular basis? Mostly not. But some are at least going to look and see where their assets stand today, and then they'll probably make a maintenance schedule based on that. Another good question, where does an engineer go to find the understanding of reading these reports?
The understanding of reading a pipe inspection report, well,
I would go through and look at Chapter 27 of the LRFD. I would download ASTM 1840. As you can see on the screen, there are a multitude of resources as far as ACPA is concerned. You can, as Doug mentioned, it would also be helpful to contact an ACPA engineer that could provide some more guidance on specificity depending on where you're located in the country. But that's where I would start reading the standards that are there.
I would add something to this. Find your nearest concrete pipe manufacturer and visit their facility and have them demonstrate a 3-edge bearing test on some concrete pipe, and you will be able to observe how the pipe performs under loads, and you'll be able to eyewitness what that pipe looks like through different stages of cracking and under various loads. So the combination of those things would be, you'd get a very good, thorough understanding of how to evaluate a pipe, a concrete pipe. Kim, are you still on?
Oh yeah, sorry, I'm talking on mute. I always have my best stories when I'm on mute. I was just mentioning that if you can let us know, you can email me where you're located. We have engineers across the country that will be more than happy to sit down and help you develop either a post-installation inspection spec for your agency, or as an engineer, what would you need in that specification, and then help you understand how to read those reports as they come in. So those are great suggestions that Sarah and Doug made as well. So far, this is our last question that we haven't answered yet. It talks about cleaning is required for RCP, but do they let the pipe dry before a CCTV inspection? Otherwise, won't you mix water with infiltration?
So maybe they're talking about the groundwater environment and dewatering the groundwater. I mean, typically what we see is the pipe is jetted and cleaned, and you know, again, we're coming from the Florida perspective here. It's a moist environment,
Yeah.
and so I'm not sure you could ever expect to, quote, dry the pipe. So the pipe is probably going to have some type of moisture in the wall itself that you're going to just have to deal with.
And I would also say that even if it was wet from previous flow coming through, that's actually the worst case scenario for crack environment. You're going to see more cracks when it's wet, so that actually may be a little advantageous. And if there is water on the level 1 infiltration on the inside of the pipe, that's a moot point, because that's an acceptable criteria to have that there. So that I don't think. And as to Doug's point, we're here in Florida probably in the worst conditions as far as water tables, and I've never had an issue with being able to view the pipe wall and it being completely saturated.
Now,
I think what they're mentioning is if there's infiltration coming in and the wall is already wet, maybe you wouldn't see that, say, a dripper or a weeper, because that wall is already damp. But I think, Sarah, you make a great point on cracks actually look larger when they're damp in a CCTV video. So it's a little bit of give and take, I guess.
Well, typically, Kim, if the pipe wall is wet and there's some additional infiltration coming through, you are going to be able to notice that, because the water is going to be running on the surface of the pipe. That's typically my experience. I mean, if the pipe wall is wet and there's additional infiltration coming, that water is going to be flowing, and it's going to then get into a more severe infiltration condition that you can determine or assess through the video.
Okay, great. Yeah, I think that addresses what they were asking. That's perfect. Okay, well, that's all the questions I see so far. Again, thanks for joining us. Appreciated it. If you have any comments or feedbacks, and especially if you have any topics you'd like to see in the future, please let me know. We'd be happy to accommodate your needs, and we hope to see you in April. Thanks so much, Doug, Angel, Sarah, for the presentation.
Thank you, Kim.
Great job.